Okay, let's get back to it then. Site approval. Site approvals will last for 5 years. You know, right now, our site evaluations kind of last indefinitely. There's never been a deadline on them. But now they're going to give us a 5-year deadline. Now I'm imagining that in 5 years, if you are opting to go have us look at that property, we can probably, quote unquote, renew it just by simply looking at it and say, okay, yes, everything looks the same. With the exception of, and this does happen, someone goes out there and grades the snot out of it and it's all been destroyed. So that is an exception, but it's a 5-year site evaluation term based on the new code. Permits, we talked a little bit about this earlier, about the deadline and the grandfathering. A permit is valid for 1 year. The board may extend a permit for an additional 6 months. So when someone asks the question, can it be extended? Well, according to this, it can. Please don't tell people you got 6 more months. That may or may not be on some of these grandfather systems. Permits are transferable between properties, and then certainly, this happens, they can be revoked, or we might have to change the system type if they go out and destroy it. And we talked about one of those earlier already. Incremental repair. Now, I don't know that anybody has a real good established way of doing this yet, but it is, when it says it's required by statute, that means it's required that we look at it as an option. There are some systems, there's no incremental to them. For example, if you have a 1/4 acre lot and your leach lines fail and you need an aerobic system, I don't know how you can do an incremental repair on an aerobic system. It's got to be in or it's not. It's all the pieces parts.
Start with the disc.
Yeah, that's one way to do it. So anyway, we have to look at that as an option for people, but in some cases it's just not an option. But there are times that it is, where you can add some leach lines, get the public health nuisance to quit surfacing on the surface of the ground, but it's not a full-fledged installation. So then we can incrementally, and we've done some of that over the years. We've tried to work with some of these systems over the years and been able to do some of this already. So I don't know if there's a hard and fast way of doing it, because every site's different and every approach would be different. But the bottom line is we want to minimize or abate the nuisance and then add components as needed. It's going to cost them more over the long term. It's like having interest. You're going to pay for that guy to come out on 3 occasions versus once. And guess what? We get to issue a permit every time you do it. Probably an alteration, the cheaper version, but nonetheless, over the time, it's going to be more expensive probably to do it that way. So yeah, and then here we are, the phased-in work. Conditions, we can set conditions on it when everything has to be completed. Perhaps some soil evaluations need to be done, and then certainly water usage. Conserving the water is going to help that system along, or perhaps even have them replace some old 5-gallon flush toilets and put in some of those wonderful 1.5-gallon flush toilets. Maybe something like that. Construction drawing, this is the as-built drawings that are required. Basically, it just kind of set some minimal standards for those. 8.5 by 11 paper, legible. We appreciate it when it's legible. Copies must be provided to the homeowner and the Board of Health. So you want to give the homeowner a copy as well as us, and certainly keep one for your records. Put on construction design measurements. And I wanted to highlight this piece here because sometimes we fail to do this. We want to make sure we begin, if we're not doing it already, we're on top of this. The elevations, the vertical benchmark, and some elevation readings throughout the course of the system, so we can see that there's been fall installed into the system, and it'll help you also to find some of these components too with the vertical elevations and being able to determine some of their depth. Has anybody tried lately, if you had no record on file, to go out and probe for easy flow, especially if they did a good job grading it? It ain't easy finding this stuff. I went out there, or SB2, that's another one. There's been some of that. Without a map, I don't know how I'd have found it in some cases. You probe
every 6 inches.
Go right through it. So anyway.
SB2, you get a football and it shoots at you.
Some that work okay don't. Anyway, keep those things in mind to find this stuff. Okay, let's move into flow estimations. Similar to what we've always done in the past, bullet number 2 there, 120 gallons per day per bedroom. That's what we've always had for a number. And they clarified, because what happens sometimes, this is what I hear sometimes. We'll go out to a property and we'll say, hey, your system's blown out, and they have a vent counter, let's say. And we find out they're using too much water. And then I'll say, well, you're using 360 gallons per day, and that's too much. Whoa, no. Your system was designed at 360 gallons per day. No, that's not how this works. This law has now clarified this. 360 was peak estimated flow, peak. We don't expect you to do that every day. You might do it on an occasion. So this next one, average daily design flow. You really should be putting out more than 60%. And if you look at the sanitary engineers' numbers they use, and when we have done event counters on average households, they're 210, 220, 60%. So anyway, that's been put in there to kind of cover your butt and my butt, so that we talk to these people and they say, I got 10 more gallons to go. That's loaded up. That's not the way it works. Not the way it works.
That's not how any of this works.
Yeah. Well, it's only leaking a little bit.
Tom,
Yes.
what number are you using per person per day, just in casual usage?
Well, the laws does it by bedrooms.
Well, I understand that.
It's 60.
Like you said,
Standards say
there's
100
10
per
people in the
person.
house and it's a 2-bedroom.
Yeah.
I mean, is there a number?
Well, you could do it a couple different ways, Fred. You look at the literature, you might, what, Fred, you saw 100 in the literature?
Yeah, the 10 state standards, which is basically 10 engineers from 10
Yeah.
states got together and said that, hey, this is what we are going to use as a basis per person for design flow going into a sanitary sewer. So,
Yeah.
and
I've heard numbers like 60-ish, because you've got 120 gallons per bedroom, and you can put 2 people in a bedroom. This is all theoretical.
Yes.
And 60 gallons per person. So I'd tell you 60 to 100 probably is a pretty safe range.
which is
That
kind of
is each of standard.
Rule of thumb. 120 is your standard. That's what you have to go by.
Todd.
Probably depends on hygiene too. That's a joke. Go ahead, yeah.
Plus or minus.
Do we need to do a water study on some of these people where the systems are blown out all the time before you design the system? Just put a water meter in or have them track stuff?
We
use a
actually
water
have,
softener?
okay, Paul's asking a question, what if you have a system needs to go in, you suspect a high flow, particularly if you've got a system that was recently installed and blows out in 2 or 3 years. We have asked for water meters to go on, and we've told them, you got 10 kids. We have no idea what you're putting out, but it's obviously too much. And if I go out there and put another replacement system of similar or slightly larger size, it may not be big enough for you. So we have asked in questionable circumstances for that to happen. Sometimes it's like pulling teeth, but they don't realize that, how else do we know? Particularly on gravity systems.
But under statute codes, are you allowed to make them go bigger if the house is only 3 bedrooms?
Jim, I think, and I'd have to
That's where you
find,
get into the study.
Yeah, how about
I'd have to
5,000
find a
gallons?
section, but
5,000
we are allowed to increase
Yeah, we just did
flows
one. We designed a
if we,
6-bedroom.
if there's fixtures or other reasons to do it. So you got the big garden tub, you got a family that's got 3 bedrooms but 10 kids. I'd say yes, we'd be well within our rights to try to do that.
Well, that's what I was
We've
wondering. I
done
didn't know
that.
if you had to stick to the 120 gallons.
Not necessarily, not necessarily.
I mean, you've done it with us before. We've increased the systems. The homeowners actually said, we use a lot of
Yeah.
water.
Yeah.
That's voluntary though.
Yeah, tell us ahead of time, yeah.
No, it wasn't voluntary. Give them an option.
All right, moving on to tanks. Tank capacities are the same as where they're at today for systems. 1 or 2 bedrooms, 1,000 gallons. 3 bedroom, 1,500 gallons. 2 compartments or 2 tanks. And 4 and 5 bedrooms is 2,000. I stopped there. There is one for 6, and there is one for small flow system designs, but we won't go over that today. Those of you who do tank manufacturing, January 1st, 2016, they're talking about having a director's approval for those septic tanks manufactured for use in Ohio. So I don't know much about that. You might want to read that section a little more carefully or contact ODH if you want more information.
So if you have a tank custom built, he's got to get it approved for like a pump tank or,
I don't know.
we're getting these bigger and bigger,
Yeah, I
pump
don't
tanks.
know the answer to that. I'm thinking the tank manufacturer's going to be approved and have various products approved, but I can't.
I'm looking at the spray, the minimum is 1,500 plus 500 per bedroom.
Oh. We'll have to see about that. I mean, it'd be ridiculous if you need a special tank and he needed to get that approved.
Oh yeah,
for
you're
that
gonna drive
special
the tank price to the roof.
Yeah. And there'll be a website that you guys, once this happens, if you have a tank manufacturer that you're like, I'm not sure if that guy's approved or not, you can go onto the website here after 2016 and verify that their tanks are approved by the director. Tanks, pumps, and controls. The one thing I want to point out here, because we don't always see it, is it now does require a quick release or quick disconnect for the on a pump for service and maintenance. So some guys don't do that, and you do need to do that now. All right, we're going to get into. I just skimmed right across that stuff, and there's probably much more to be said, particularly about pumps and controls. But we're not, for the sake of time, we're not going to get into that. I do want to get into the meat and potatoes, and that's this. This is where you guys, as septic installers primarily, need to really understand how some of this is changing, and how it affects your daily operations and so forth. So what this is a table of the vertical separation distances, most of which you're accustomed to. The 36 inches to bedrock, 36 inches to groundwater. And then you have this minimum in situ or native soil thickness. You can't go any closer no matter what you do, no matter how many pre-treatment devices you put in, than 12 inches to groundwater, 12 inches to bedrock. So all that stuff is being covered here. And this is a table that's in the rules, and there's the verbiage spells it out also. So there's a lot of different soil characteristics that have various levels of risk associated with them that are spelled out in this table. So bedrock has the highest risk. Then you get down into seasonal perched water table, which if you recall in 07, this was, in my estimation of things, that's what killed 2007 rules, was that. Seasonal perched water table, vertical separation distance. It was just a mess. So many people were putting it in the water tables, seasonal water tables, that they just couldn't come to grips on that kind of a change. So now it's come back. This tells us the state law allows every Board of Health, if they so choose, to establish a minimum vertical separation distance to seasonal water. And that law says we can do it from anywhere from 6 to 18 inches. You choose. So whenever, you need to know this, because as you work in other counties in the state, you're going to find that everybody did this different, and guess what? That means your system designs are a bit different. We want to state consistency, but it's not necessarily, and primarily because of that. Okay? State of Ohio said if the local health department doesn't choose to adopt a vertical separation distance, they give you a default, 12 inches. This rule that I talked about earlier about O&M, most of it's about O&M, but in the back page, establishment of vertical separation distance. Our Board of Health did adopt 12 inches. However, the state minimum here was 8 inches. 8 inches of in situ soil for the distribution of septic tank effluent. 8. The board took it to 12, so it's 12 and 12. 12 inches of vertical separation and 12 inches of in situ unsaturated soil to be present underneath the soil absorption system to the seasonal perched water table.
5%.
Pardon?
That's at 5% modeling.
I'm glad you brought that up, because that's in my notes to tell you. It's not in any of the stuff that I have to show you, but the definition of seasonal perched water table has changed. It used to be 2% modeling, create certain depletion colors. The soil scientists, they use these different colors to determine depletions or modeling. It went to 5%. So you that sit in the room are soil scientists, that line that you draw on our page, it tells us where that's at. You might be lowering that line a little bit to 5% instead of 2%. You know what? There's a lot of times it makes a big difference. Several inches in many cases. So anyway, the law established these. Many of these are you're already accustomed to, but the biggie that's really driving costs and design is that one right there. Septic tank effluent, vertical separation distance. So how can I reduce them? If I need to reduce vertical separation distance, what are my options to reduce them? So let's say I want to get that system farther in the ground. I prefer not to use a mound system, whatever the case may be. What can I do? Oh, no, thanks. I saw me stuttering. I need more coffee.
Just fresh coffee.
What can I do to reduce the vertical separation distance? The first one we're going to touch on a little bit is the installation of an engineered drainage system. Not a curtain drain, not an interceptor drain, an engineered drainage system so that you actually do the math or use modeling to show that that drain will in fact reduce the water table down low enough for you to put that system at the depth you're asking for. So that's one way. The second ways are ones you're already accustomed to. A 1-to-1 equivalency for elevating. So if you put a mound in, you can, let's say you had bedrock at 2 feet and you need another foot. You can put a mound in with a foot of sand material, then put your distribution system on top. You would then meet the 3-foot vertical separation distance if that's how you wanted to do it. Another option would be to put a pretreatment device to do something, to buy credits and put it down in. And that's actually number 2 there. Number 2 is using a pretreatment device to clean it up some and get credit for that vertical separation.
How much credit can we get?
I think it's still 1 to 2 feet, just like it says in the chart.
So we can go, but you can't get closer than 6. So you can do
I think
6 inch credit.
yeah, okay, that's another one. So the other thing that the state law said was the Board of Health should adopt a vertical separation distance for pre-treated effluent. And that distance had to be, they gave us a range again, it's no longer 6 to 18, it's 0 to 6. Pick something between 0 and 6. We picked 6. Personal view, and as I have historically looked at systems and how well they function, 0 is not a good way to go. So we picked 6. You can get 6 inches off of the seasonal perched water table with a pretreatment device meeting the right specifications.
How'd that go with the builders?
I didn't tell them.
Now,
Yeah.
is that just an aeration, or you include an LPP or flood dosing then?
I'd have to read how that. You know what, Paul? I have it right here. Let me see. Let's see how that's actually working.
Summit's doing 6, or was doing 6 with an LPP.
Okay, here's how it reads. In this language, all I did is I took it out of the state law and I just inserted our numbers. So this is the same, the wording's terrible, to be honest. A minimum vertical separation distance of 6 inches and a minimum in situ soil thickness within the vertical separation distance of 6 inches, 6 and 6, just like it was 12 and 12, may be used where the seasonal water table is present and the sewage effluent is pre-treated to less than 1,000 fecal coliform per 100 milliliters. So we're talking pre-treatment, not other methods.
Yeah, and you're talking less than 1,000. That's basically
Is that in a PDS?
Yeah.
Okay, I don't recall.
Just an aeration won't get you
UVA.
in.
Aeration don't-
You got UV.
1 foot soil depth credit doesn't get you there, huh?
No.
The 2 foot one?
Yeah.
So the 2 foot. So you're talking all the
All.
goodies. Yeah, you're talking all the goodies.
You probably don't need re-air, but
Yeah, but
that's
you'll
the
need
minor
the
part.
UV. You need the UV.
yeah, you
though.
need UV.
Okay, good to know. All right, the third thing